The silent intelligence.
I'm going to say it's my absolute pleasure to interview Ariel Garten from InteraXon. And we met, 4 years at the CES when you brought this little tiny prototype with a couple of sensors, and back at that time you just had a vision for mind-controlled computing, and it's so exciting to see you with this device here and having, how many users do you have now?
Tens of thousands of users.
Tens of thousands of users. It's very exciting. To tell us more a little bit about Muse and about InteraXon.
Sure. So as you know, this is Muse, the brain sensing headband.
Mm-hmm.
It's a brain fitness tool that helps you do more with your mind. It's a clinical grade EEG in this slim little package, and it slips on just like a pair of glasses.
Mm-hmm.
You've got sensors on your forehead and behind the ears that send your data to your smartphone or tablet.
Mm-hmm.
From there, there's a range of applications. So the application that we've built first is a mindfulness tool.
Mm-hmm.
And as you use it quite often, you know, it helps you build states of focused attention. So if you're trying to get into mindfulness and you're not really quite sure what to do, your doctor told you should meditate and you don't know how, this teaches you what to do.
Excellent. And I'm actually a big fan of Muse, I have to admit that. So how does it teach people to meditate?
So what you do is you actually hear the sound of your own mind.
Wow.
So
how does that work?
Yeah, so typically when you meditate, you're like, am I doing this right? Is my mind blank? What's going on? So Muse actually tells you when you're in a state of focused attention and when your mind is wandering.
Mm-hmm.
So the metaphor we use is your mind is like the wind. So when you're thinking, distracted, ruminating, you actually hear it as windy. And as you come to a state of clear, focused attention, you quiet those winds.
Wow, that's very exciting.
Yes, it gives you real-time feedback to help you understand what's going on inside. And then there's stats and charts and graphs to actually track the meditation. It's gamified as much as that's, potentially counter to meditation, but then we find other ways to ungamify it at the end. So it really motivates you and engages you into your practice.
So it's allow a person to learn how to be more focused?
Mm-hmm.
Wow.
Allows a person to learn how to be more mindful overall.
Mm-hmm. Excellent. And focus is probably one of the top performance. What focus drives performance, essentially, right?
Yes.
So it basically allows people to learn how to perform better at their job.
You've got it. So if you think about how often you try to read something and you recognize that you're thinking about something else, or in a conversation, you're no longer listening to what the person is saying, Muse teaches you how to avoid all of that, how to really stay in the thing that's in front of you, the thing that you want to do.
Mm-hmm.
And it doesn't just teach you focus, it also teaches you how to manage your own stress. So it teaches you how to manage the world outside and also manage the world inside. There's negative thoughts, the feelings, the emotions, the stuff that comes up that can get in the way of your day.
Mm-hmm.
It teaches you how to manage those and deal with them.
Well, managing stress, I think that's a big thing. I think stress overall is on the rise, and it's a very timely application for sure. But how did you come up with Muse? How did this whole idea came to you?
So we actually started in the broad scheme of thought-controlled computing.
Mm-hmm.
So we started by creating applications that you could literally control with your mind.
Mm-hmm.
We got to control the lights in the CN Tower with people's thoughts from across the country. We've done things like thought-controlled beer taps and thought-controlled toasters and thought-controlled games. Now the control is still very basic. It's typically based on focus and relaxation, but it is true control of an external device. And from there we recognize the most important thing you can do is actually learn to control your own mind. And so we created applications that help you understand what goes on internally.
Based on you have tens of thousands of users. How steep is the learning curve? How hard it is for somebody to learn to control their mind and learn to relax and learn to focus?
So you start with an exercise that's just 3 minutes long. So in 3 minutes you hear what goes on inside your head and you begin to understand how you can actually gain management of your own thoughts. Our mind goes like this all the time, and this teaches you what to do to bring it like this.
Wow. And now, when you look at going beyond a little bit of those applications like focus, and what are the next things that you envision for Muse? What type of applications do you see?
So Muse is actually an open platform, and we have hundreds of developers right now building on top of it. So people are making everything from games that you play directly with your brain to less meaningful applications like thought-controlled drones, things that are really fun explorations, to really serious applications like games for kids with anxiety or ADHD.
Mm-hmm.
We have over 50 research institutions currently engaged with Muse. Mayo Clinic is running a study on stress reduction in cancer care patients using Muse. We have studies looking at sleep, anxiety, depression, looking at neuromarkers for disease. So there's a broad range of applications that's available when you start to engage directly with the brain. And there's so much that we can learn there that will become part of verticals from education through to sports and fitness through to industry.
And your background is neurosciences, is that correct?
Yes, correct.
So how realistic do you think that it's possible just to avoid medication and let people teach themselves how they can heal certain mental disorders?
So ADHD is a great example. There's a biomarker for ADHD that's called beta-theta ratio. It's been recently approved by the FDA.
All right.
Kids with ADHD have high levels of theta waves and low levels of beta waves. By teaching a child to upregulate their beta state, focus, and downregulate their theta, dream state, you can do something like drive a car with your beta-theta ratio, drive a car with your focus. When you do that successfully for 20 sessions, you're able to improve your ADHD symptoms as effectively as Ritalin.
Wow. Does it only work with kids, or do adults can do the same thing?
Adults can do the same thing too.
Does it take them more time, or?
So a child's brain is more plastic than an adult brain, and the study that I referenced, 20 sessions can have efficacy as effective as Ritalin, was based on child brain. But we certainly have lots of adults that have been using Muse for their focus or what they self-diagnose as ADHD, and they found it very impactful.
That's very exciting. And from ADHD, what about like bipolar and some of the other major disorders that we're seeing?
So there's a lot that we can't do. I mean, there's no cure for Alzheimer's in the device. There may be decades in the future, but not one that we can certainly see now. But for something like bipolar, the depressive aspect of bipolar can be managed in part using Muse, because neurofeedback for depression is actually quite well known. So both with the mindfulness aspect, mindfulness for depression has lots of studies that validate it, and the ability to do neurofeedback on your left and right brain hemispheric specialization. So people who are depressed tend to have low left frontal activity, people who are happy tend to have high left frontal activity, and that's actually been used as both a biomarker and an intervention for depression.
Excellent. Have you seen the movie Big Hero 6?
Yes, I love it.
Yeah, I loved it too, and my kids love it too. And actually, he's controlling things with a headband, right? Did they borrow this idea from you, or?
So, we're not the first people to do it. There's lots of research labs that have been building brain-computer interface technology for quite some time. Originally used with patients with ALS, that was the first greatest use case. And our part of the kind of ecosystem in the story is bringing technology to the next generation and really making it consumer with very compelling applications that bring meaning into people's lives.
So, how?
Though I will note that the headband did look like ours.
It did. It certainly did. So, how much do you see those applications like controlling drones and doing more of a mind control computing that you mentioned earlier? How much do you think they're like getting traction, or is this more of a gimmick to get people's awareness to more serious applications?
Yeah, from a control perspective, as I've said, it's still very, very basic. We're at basic stages of the technology. You get 1 to 2 degrees of freedom. Nothing that you can't do better with your hands if you have the ability to use your hands, which is why it became so popular in populations with ALS and other movement disorders that didn't allow them to engage with the physical world, with your physical body. So right now they tend to be, fun gamey things. It's going to be a good decade or two until thought-controlled technology takes off.
All right.
And probably before thought-controlled technology, we're going to see responsive technologies. So devices that know something about your state and use that contextual computing to understand how to interact with you and support you. So for example, your phone could know that you were asleep and stop ringing, or know that you were focused and not push notifications to you.
So I wanted to go back to some of the things that you said earlier, that it's possible to detect like ADHD in a person using Muse, for example, using EEG information. And that might freak some people out, because they definitely can start being concerned about privacy and so on, who can get access to this data. So what are your thoughts about this? What do you think about making the data private and also securing the data?
So this is one of my favorite questions, because it's one that I feel very passionate about. I actually created an organization called CEREB, the Center for Responsible Brainwave Technologies, and that creates a set of standards for the entire industry around privacy, safety, efficacy, security, and transparency. And so on the privacy side at InteraXon, our deep belief and our sole tenet is that you always own your own data. The user always owns their own data. And terms of service have to be extraordinarily clear so that you know what you're consenting to. And we don't allow third-party uses of the data that are unethical or that a user would in any way object to. And any third-party use always has to be explicitly consented to. So I am highly, in case you can't notice, highly
Right.
passionate about privacy and ensuring that the entire industry plays the same level of privacy standards.
So your third-party developers, they have to go through certain consent and...
Yes.
All right. Excellent. So...
I should also mention, you mentioned Muse being used for ADHD. Muse is not a medical device. You know, we don't
Right.
consent or
Right.
endorse the use of Muse for ADHD. If somebody chooses to do that, that's their own off-label
Totally,
discovery
yeah,
and decision.
totally understood. Now, how hard it is to get the FDA approval for wearable devices these days?
So FDA approval, you know, it's the same process for anybody. You have to go through either a 510K for medical FDA approval on the device as a med device status, or you go through your trials, and at the end of your trials, your RCTs, you can then apply to the FDA, and it's typically about a 3-year process. So we
All right.
have a number of trials set up that could go down the FDA route if we so choose.
Don't you think that 3 years is just awfully too long for innovation?
It's unfortunately long for innovation, so it's very difficult to truly be innovative. On the other hand, I entirely respect the need to have standards and regulation to ensure that everybody's kept safe.
But do you think it needs to change? It needs to maybe match the pace of innovation in the wearable tech that's happening right now? And go from 3 years to maybe 12 months or something, or 6 months?
That sounds fantastic. Well,
But do you think it's feasible, and do you think it needs to be more effort put into it?
So part of the problem with it being, 6 months or 12 months is if you're truly going to come up with a rigorous standard of care and indicate that yes, this device does no harm, and yes, this device is efficacious across, broad populations with great statistical significance, that proof takes time. So setting up those trials, that's a year and a half. Could the FDA process be shorter than 3 or 4 years? Absolutely. But I think there's something valid to the rigor that it engages.
Totally. So I was going to ask you also, how do you involve insurance companies and healthcare institutions to participate in the whole wearable innovation? Because you're generating a lot of valuable data. Plus, you have a significant sample, tens of thousands of users. And historically, it's probably, correct me if I'm wrong, but it's never been possible to collect the sample data, EEG, from so many users at the same time, right? So how do you get the institutions that can most benefit from this data involved? They can really participate in the ecosystem.
So we've been really open and really great at building relationships with institutions like Mayo, universities like University of Toronto, UCSF, et cetera, et cetera, et cetera. And for us, we have a strong research program. As a scientist, my background comes from science and building great studies and building great research relationships. So for us, it's been really easy to build and capitalize on those relationships so that we can all do good science and make good discoveries together.
So I really enjoyed the conversation, and some of the final questions that I wanted to ask you. So first, how do developers work with Muse? If somebody wants to develop an application, what do they need to do?
So the SDK is open. You can go to our developer website, which you can find just at choosemuse.com and click on the developer tab. And from there you can download the SDK. You can use inputs and outputs that are standard focus and relax scores, so concentration and mellow, or you can build your own algorithm.
Wow.
And you can start to plug and play and build brain computer interface applications.
Super. And finally, what's your couple of words of advice to aspiring startups that want to get into the wearable space after everything that you've been through? What do you think they need to pay attention and focus on?
So everybody always says hardware is hard, and that's absolutely true, but that's not a reason not to do it. You're going to have a really great hardware team, software team, logistics team, marketing team, sales team. There's a lot of infrastructure that needs to be built out, but there are really effective incubators that are popping up specifically around hardware. One of them is out of PCH Highway 1. They're manufacturers who've actually brought together a hardware ecosystem, and they guide you through what to do. I wish it existed when we were building. Another piece of advice is you're going to find value at many points in the chain in what you're building. So you may come in with a very specific and very targeted use case, but be simultaneously laser focused on building a device, getting out to market to a target user, while at the same time very aware of the other places that your device can go and the other models that will allow you to build value inside your own ecosystem. because you may have a great idea and then recognize that it's so much bigger than you actually thought. So don't become overwhelmed by the idea, stay focused on building something, but always keep your eye on the various other prizes and how you can build value for the ecosystem overall.
That makes perfect sense. Thank you very much.
My pleasure.
Really enjoyed the conversation, and good luck.
Thank you.
Thanks.
The Silent Intelligence. Learn more at www.thesilentintelligence.com.